with that, I'm going to pass the baton to Brian Orlowski. Brian's the Dean of Technology at Mount San Jacinto. Brian, take it away. Oh, and by the way, this is a quote from Brian. He was kind enough to not only bring us in to be his partner, but to give us a nice reference in terms of the story of the actual solution and the work and the success, and a nice quote that we've put on the screen. So Brian, I'm going to pass it to you.
Great, thanks, Scott. As Scott said, I'm Brian Orlowski, Dean of Information Technology for Mount San Jacinto College. It's good to see some familiar names on the attendee list. A little bit about Mount San Jacinto College, because I'm sure not all of you know about the college. We are a California community college in Riverside County, California. Let's see, we cover about 1,700 square miles from basically just west of Palm Desert, just east of Riverside, and down to the Temecula area. We've got about 20,000 unduplicated students per term. And for those of you that care about full-time equivalent students, right about 12,000 full-time equivalent students. I guess I don't have to tell you a lot about what Mount San Jacinto College has been going through. You all are probably in similar situations with moving classes online, switching to a remote workforce, all that sort of stuff. But how we came into this process, I think we were pretty well positioned. We have a history with InterVision. About a year and a half ago, we took possession of a new building in Temecula area to stand up a third main campus. During that process, we were planning on building out, it was a Class A structure. We purchased it from Abbott Labs. It was medical grade, had a state-of-the-art data center in there. And we're planning on transitioning our server closets and MDFs really from our other two campuses into that data center. That data center was commandeered by our student services area, specifically financial aid. And so we had to find a solution for our data center. And in conversation with our executive team, we decided that we were going to make a move that was cloud first, native first. And when we went through the evaluation process, and we developed a partnership with the California Community College Technology Center, we identified that we wanted to go with AWS. Through that collaboration with the Technology Center, we got some strong recommendations for InterVision. And over the past, since I guess it's been about 10 months now, we've had a relationship with InterVision, and Jay's been our solutions architect, our solutions engineer. And we've been working on being one of the first community colleges in the state to take our student information system, our ERP, to AWS. Right behind that, we're planning on moving our entire data center to AWS. And so Jay's been working with us on that project since about the September timeframe. So when we got the orders from Riverside County Office of Health to basically move all of our classes online and move to a remote workforce, quite honestly, I think we were pretty well positioned because we already had Jay in our back pocket. Kind of fast forwarding, I think it was March 20th, and I want to give some credit to Ventura College because we saw a demo from them on AppStream. It was in the morning. I think it was like 9 a.m. And I think it was about an hour and a half presentation. And Mike Rose down there did an outstanding job on the presentation. Immediately after that presentation, we got on the phone with AWS and we got on the phone with Jay from InterVision, and we started talking through our use case scenario. And to support our remote workforce, we identified 5 primary applications that were on-prem that our employees did not have consistent remote remote access to that we thought were critical to maintain the business functions of the college. Those were our colleague user interface application, which is the front end for staff to access our student information system, our on-base document imaging system, our SQL Server reporting services, a application called SARS Anywhere, and that's used primarily by our counseling and categorical departments to schedule appointments for students and track reason codes for our mandated reporting to the chancellor's office. And the fifth one is our Galaxy system, which is the financial system provided by the Riverside County Office of Education. We thought if we could provide those 5 applications to our remote workforce, we could keep them functioning. So we got on the phone with Jay, and just a little background, we had been working with Jay. We had a VPN, site-to-site VPN set up between our local network, on-prem network, and AWS already. And so what we decided was, and we partnered with AWS as well to talk through licensing, expected costs, all that. And we made a pretty quick decision, really within an hour, with talking with our executives, to actually move to AppStream for these 5 applications. And this is going to sound pretty remarkable, but I think our first discussion about AppStream with Jay occurred right around 11 a.m. on that Friday, March 20th. And by the evening of Saturday, the 21st, we had 4 of those 5 applications ready to deploy or deployed in a production environment, authentication resolved. And on that Monday, we actually started the day scheduling, I believe it was 8 a.m. We started scheduling training sessions. We performed training for about 300 staff members Monday and Tuesday, and we had people accessing the system, AppStream, Monday and Tuesday, actually accessing 4 of those 5 applications. I say 4 of the 5 because our Galaxy financial system, we had it installed. We had it about 80% working, and Riverside County Office of Education wasn't supporting the installation. They would only support a Windows 10 install. So we're still working with them on that. They're trying to assist us, but it's a really old technology, and they're just struggling on their side supporting it. And so I think that's all I had, Scott. What did I forget?
I think you did a great job, Brian. And I think the only thing maybe for some of the folks on the line, I know some folks are interested in student applications. I know you guys have talked about that. There's technically really no difference between, deploying AppStream for a student application versus the admin application. But if you have a perspective on that for your college colleagues that might be interested, maybe just, a couple minutes and we'll pass it to Jay.
Yeah, so the Chancellor's Office has provided a lot of technologies very quickly for us to implement on the student side. And what we didn't have support for across the system was any sort of solution for remote workforce. Our priority was to get the remote workforce stood up, and then we were circling back to bring all of our classes online. So right now we're evaluating from the student perspective, what student applications hosted for students should be going to AppStream. And there are some good candidates, but we're internally going through that conversation now. We're just because of the ease of few reasons why we chose AppStream. One, our remote workforce don't have dedicated sanitized devices. And so we wanted to encapsulate that risk by having them log into AppStream where we could control the interaction with the applications. Another reason was for the ease of configuration and being able to configure once and roll out to many. And I think we see some of those same benefits for student use as well. So yeah, I think from the administrative side to support a remote workforce, it's been a good solution for us, and I think it very well could be a good solution for rolling out applications to the students as well.
Great, thanks, Brian. I'm going to pass the baton, or maybe that's you, Chris, to Jay. And Jay, you can take it away, unless, Chris, there's any questions that have come up that you want to ask right now.
Not so far, but I'll go ahead and pass things over. Jay, you should have the opportunity to take the presenter role now.
All right, so I'm going to share my screen here, and then we'll get started.
Perfect.
All right, so hopefully everybody can see my screen right now with the web browser.
Yeah, we can see it fine, Jay.
Great. So Brian gave a great description of why I chose AppStream, and so I'm going to focus on what the user experience looks like and what the admin experience looks like, and we'll look at a diagram also of what the AWS architecture looks like. So starting off from what the user sees. After users log in to AppStream, and this could be through whatever identity federation source you already have, they get to this portal in AWS, which is branded to look like Msjc's own infrastructure here. And then they get a list of applications in the catalog that they can access. And I'll just show you one of those real quick, what it looks like. So this is the SARS Anywhere application. As you can see, it's opened in a web browser within my web browser. So it's actually streaming the application over through AppStream to me that way. And in this case, we elected to leave the title bar here where you could change the URL if you want, but you can also launch the browser in kiosk mode where that won't show up, and it would just look like the user is, all the user would have access to is what you want them to see, basically would be the URL which you provide. And we'll look at how that's configured in just a minute. But from there, let's move over and take a look at the architecture diagram. So this is the architecture for Msjc, for AppStream in general that we build out under this offering, but it's also what we built out for Msjc. And you'll notice a few things, in particular, the VPN in the center of the screen here. There is a VPN running from AWS to Msjc's infrastructure, and it's a dual tunnel VPN for high availability, and it connects to something called a transit gateway in AWS, which if you're not familiar with that, it's basically a router in the cloud. And the idea behind the setup here is that we're trying to build out a solution that is scalable. So if you're new to AWS, after you've adopted it for AppStream and you want to expand and have other use cases, the transit gateway would allow you to connect other different AWS environments you might already have or will have in the future back and have them all share the same site-to-site VPN connection back to on-premise. But for AppStream specifically, we've put the AppStream resources in their own account, and that allows us to encapsulate the application as far as security and cost go. So if you have a specific department who would receive the bills for AppStream versus maybe other pieces of your AWS environment, then it would be easy to do that because the bill for this account would only contain AppStream. And then also you can limit who has access into the AWS account itself from an administrative perspective by using permissions on the count at the count level, as opposed to having to restrict down at the application level or service level in AWS. So you notice that the AppStream account is connected to the transit gateway with an attachment. So it lives in its own VPC, which is private inside AWS. And the way AppStream works, you tell it what kind of applications you want to install through a process, which we'll look at in a minute. But once you have your applications installed, then AppStream deploys the services to users via a fleet of, they're basically EC2 instances behind the scenes with an auto-scaling group in place. And all this is deployed within a private subnet that is basically local to your on-campus or on-premise network through the VPN. So we're using a CIDR block range here that is not in use on-premise, such that anything here can be routed back to on-premise, and then on-premise can route back to it as well. The AppStream application is accessed by users via the internet, so it exposes an endpoint for AppStream onto the internet, and the authentication through that can be set up in two different ways. You can use a built-in function that AppStream provides called user pools, where you can define users within AppStream itself. Most of the time, most people are going to want to use an existing identity provider that they already have. So we have two options shown here on the screen. And in MSJC's case, we used PortalGuard to do that, but this could be anything you want that's SAML compatible, basically. And so once your users are logged into whatever your identity provider is, they basically assume a role into AWS that takes them directly into the AppStream interface. You also notice we have some AWS directory service instances over, and they're in this account here where the transit gateway is, which we're calling the central services account. It'd be the place where you'd put any components of your infrastructure that are sort of central to your AWS deployment. And AD is one of those things, of course. So if you have on-premise AD, basically, and you want to use that to resolve DNS from AWS back to on-premise, then we set up these directory service instances. And in the MSJC case, the applications that are being exposed are actually on-premise on these servers, and AppStream is accessing them over the VPN. So the applications are web-based, and when the web browser opens to say colleague.msjc.edu, the DNS is resolved by going through a domain controller, and then it's able to route back to the actual IP address, the private IP address on-premise. So this is a solution that basically eliminates the need for a VPN, since the AppStream endpoint is public. That allows the users into the environment, and it encapsulates what is essentially a local application that's, for all intents and purposes, on-premise, since it's connected back through the VPN to the data center at MSJC or wherever your on-premise location might be. From there, I think it's probably best, unless anybody has any questions on this, we can jump into the console.
I think, Chris, are there any questions, or do you want to keep going?
We're good to keep going. I'll let you guys know if we haven't. And yeah, to the audience, just as a reminder, you can use the Q&A or the chat functionality to ask a question, and I'll be sure to chime in.
Thank you.
Great. And this solution is flexible. This is the way we would ideally deploy it. But if you already have an existing AWS infrastructure, this can definitely be changed around as needed to work in your environment. So moving over to the AWS console itself, this is what an administrator would see when they're actually setting up AppStream or modifying AppStream. So AppStream has several different layers to it that make up the whole application. So you start from the top, which is a stack, and a stack, as it says right here, consists of streaming resources and policies for controlling access to those resources. And the stack contains a fleet, as we're looking at the diagram, and the fleet basically deploys the images that you've created. So we'll start at the bottom and look at the images. So AppStream images are based on Windows Server, and there's quite a few different types of images you can pick. The first thing you have to do is decide what kind of image you want to use, and then you launch an image builder from that, which is where you install your applications. So AWS offers different versions of Windows, 2019 back to 2012, and different versions that are optimized for graphics, which this would be a high-end use case, like somebody's using a CAD program or other graphics intensive application. And they have the more standardized base images down the list below, but there's a lot of them. So you pick one and you launch it. And then once you launch it, you basically have access to an image builder, which I have the Msjc image builder running right now. We'll take a look at that. So you select the one you want to use to build, and this would, you normally have one here if you just created one from the registry like I just was showing, and you connect to it, and you're basically connecting as if you would through RDP, but it's browser based. And then once you connect it, it lets you choose a few different roles. In the case for the initial install, you pick administrator. And then you'll get access to the desktop just like if you were RDP'd in. And at this point, all you have to do is install your applications on the server. And once you've done that, then AWS provides this tool called the Image Assistant. And within the Image Assistant is where you actually tell AppStream where your applications are, which applications you want to use with AppStream and where they are. And it's pretty simple to set up. There's an Add App button here, and you just basically point it to the executable. And once you've done that, you can configure a few other things like the icon and give it command line parameters. So as I mentioned before, the applications that we're looking at right now are web-based. And in this case, Colleague is being executed through Chrome. So the application that is associated with AppStream is actually Chrome. And we've just provided a custom icon with it so that it shows up the Colleague icon. And we've provided a command line parameter to it so that it knows to load this particular URL, which is the Colleague URL on premise. This resolves back to Msjc through the DNS that we've talked about before, and the routing is handled through the transit gateway, through the VPN back to their on-premise servers, and delivered to the user through the internet. Once you can also set this up in kiosk mode if that's desired, such that the user won't really be aware they're in a browser. They'll just see a window directly to the application. There's various reasons you might want to leave the navigation window there. So it's a choice you can make. But canceling out of this. So after you have added your application, you basically go through a few steps here where AppStream is basically learning how the application behaves and optimizing it for use with AppStream. And then once that's complete, your image is ready. And then at that point, you take the image builder and make an image out of it. And once you do that, your image will show up in the image registry. And so you can see the images that Msjc has here at the top. So once you've gotten this done, then you're ready to think about deploying a fleet. And so, as I said, a fleet is the group that deploys all the instances to the users. And the way AppStream works, each user is assigned one instance, and it's not a permanent assignment, it's a dynamic assignment. There are two ways that you can run AppStream also. There's an on-demand version, which is generally going to be cheaper for most use cases, for normal business hours type use cases, where you need the instance available 40, maybe 50 hours a week, or even less. And then there's also an always-on AppStream version. Most of the time, on-demand is going to be cheaper, and we have a spreadsheet we can show pricing on all that stuff. But assuming that you choose on-demand, which is likely, then you have to basically set up scaling policies so that there is always an application server available. As I said, each user is assigned one instance. So, and what I mean by that, there has to be an instance available when a user wants to log in. And you control the users or the number of instances available through scaling policies. There's various ways to do it. One way is to use a scheduled scaling policy. So if you know, for example, that you're going to have 200 users who want to use AppStream from 8 to 5, Monday through Friday, you can configure it such that as soon as that time period or the time window rolls around, it will automatically scale up to 200 if you wanted to do it that way. And that would probably be the way to start off if you're unsure of your demand. But once you kind of use it for a while, you can look at some statistics on how much use your users are actually using AppStream. And AppStream will show you how much capacity you have total, which is the number of instances that are running. And then it will show you the instances that are actually in use. And then it will show you the percentage of that use. So you can come in and you can basically craft scaling policies based on this data. And those type of policies would be scale in and scale out policies based on demand. So you can see here, Msjc has one that if the capacity utilization is greater than 65%, so that means if I had 100 instances ready to go, 66% of them were in use, it would go ahead and add 10 more. And then if the utilization fell below 50%, it would remove 5. So if I had 49 in use out of 100, then it would drop down the number to 95. And the on-demand version of AppStream, when you have a user actually logged in, you pay the AWS's set price for that instance type. There are multiple different instance types to pick from. They have very small instance types that start at 10 cents an hour up to some very expensive ones that can handle high intense graphics loads. Most of the time, one of the lower end server types will work for general user applications. And so when the user's logged in, you'll pay that price, 10 cents an hour or 20 cents maybe if you need a little bit larger one. But when the user is not logged in and the instance is available for them to use, you pay a discounted rate of 2.5 cents per hour. And then further, if you scale down, you don't pay for any instances that aren't provisioned. So if you look at this example here, right now, Msjc has 53 that are running, 27 in use. So they're paying 10 cents per hour for 27, and then 2.5 cents per hour for the remaining 27.
Hey, we did have a question that came in from the audience that I wanted to bring up real quick, and whomever wants to grab this one. So the question is, does AppStream support an app that is not web-based?
Yes, it does. You can install whatever you want on the server. It can take a little bit longer, obviously, to do that if it's an older application. So in this particular case of Msjc's project, we worked with one called Galaxy that Brian mentioned, which is a pretty old application. I think might even be before the turn of the century. Can't remember. But it had some dependencies that caused us a lot of trouble and some really particular routing issues with it too, because it has to communicate out to Riverside. But in general, if you want to install a desktop or server-based application that's modern, it's a pretty simple process to do it. So yes, it definitely works. It just so happened in this case that Msjc's most critical applications were web-based applications.
Perfect, thank you.
Hey Jay, here's a question for maybe you and Brian. How has the profile changed from the time the implementation was started to where it is today? And if so, how did it change? And how did the scaling change, or did you need to change the scaling to adjust for that?
Yeah, so they've been tweaking it. Msjc team has been tweaking it on their own some since I last worked with them. But we started off with a scheduled policy, and as I mentioned before, when you first start off, if you're unsure of your demand, then that's the most conservative way to go, because you basically want to make sure that you always have more instances available than you have users logged in. And so if you're not careful with that, you can get in a situation where you're not aggressive enough on scaling, and you might get the user will get a capacity unavailable issue. And the AppStream environment will detect that and go ahead and add more, but it takes more time than most users would want to wait. So Brian had been looking at going from what we started with to bring costs down to rely more on the scale up policies. And Brian, I don't know if you want to add anything to that about what you've seen lately on it, or
Yeah, so the first week or so, we've got about 500 employees, full-time employees with our full-time faculty and our staff, um, and we recognize that some of those individuals were going to start back at work in times, and so while we trained about 300 people, we didn't know what demand was going to be like on these applications. So what we found was the first day we had like 10 people log in, and throughout the first week I think it went up to like 18. The next week went up to the 20s, and then ended up in probably the 30 range, and now we're hovering in between 30 and 40 peak users. So the first couple of days, we scaled it way up, and I was just trying to manually gauge where we were at with capacity. And then we started refining the scale out policies, scale in policies. And once we got about a month into it, I think we started tweaking the scheduled scaling policies. And right now, I think we're pretty comfortable with where we're at. I'm not having to go in there on a daily basis anymore and look to manually add sessions. So in this on-demand format, to add sessions to the fleet, to add capacity, it takes a good 15 to 20 minutes. So it's not something that you can really do manually as people are getting notifications that there's not a session available. So right now, I think we're tuned pretty well, and it has been a process that we've been looking at and just tweaking over time. And we've had this policy for about, I'm going to say 2 to 3 weeks, and it's worked pretty well for us.
Thanks, Brian.
yeah, and you'll notice they have right now the policy set to during the weekdays. It sets a minimum of 40 instances, and then the max is 200, and then outside of that time period can drop down lower. So it's definitely something you have to tune and work with, but the main thing to keep in mind is just to keep a more aggressive scaling policy in place so you stay ahead of demand. And as I mentioned before, the penalty for doing that cost-wise isn't really huge, because it's 2.5 cents per hour for every unused but provisioned instance. So AWS makes it incentivizes the ability to do that, basically. Let's see. So if there's no other questions on that, I'll move on a little bit. Do you have anything else?
I think we're good. When the time is right, I would love to have a comment on the duration of time it sort of took architecturally versus the deployment. I think I recall you saying it's about 2/3 of the time was getting the architecture set up and functioning properly, and then the actual deployment for web-based apps is pretty low on a per app basis, right?
Right. Yeah. I mean, the setup of AppStream itself. I mean, I don't want to minimize it. It's probably the simpler part of setting up the entire AWS environment, but there's still definitely lessons learned from having experience with it. So, but yeah, to your point, the environment that we set up here is something that we've settled on after a lot of use. And there's some questions that people have commonly about the instances or in AWS, they're in a private subnet, but what if the user who is on the instance does something that needs to access the internet? Does that traffic go straight out to the internet, or does it go back on premise through whatever our firewall solution is? And we can modify the routing rules and such that it could be either. So the environment can be as secure as you need it or as open as you need it to be. But a lot of the design time does go into getting the AWS account set up and configured, and all the VPCs built out, subnets, things like that. Let's see. So back in AppStream, I mentioned earlier about the two different authentication methods we have to choose from. There's the user pools option, which is basically a directory within AppStream, and then you can also use an identity provider as the other solution. Msjc is using an identity provider, and I expect most people would prefer to, but there is a user pool option here, and I actually have an account set up in it since I'm not part of their domain, and the login that I was showing you earlier is from accessing it through the user pools set up there. Let's look at the fleets a little bit more in detail. So when you create a fleet, as I mentioned, you choose the image that you want to use. I'm just going to pick I can actually do it all the way. So pick a sample image, and then you get to pick the instance types. And this is where you can choose some general purpose or compute optimized, memory optimized. It'll show you when you drop down is not behaving here, but when you pick the drop down, you can pick how many CPUs you need, how much memory, and there are quite a few extensive options here, all the way up to 384 gigabytes of memory, or gigabytes actually they call it. And then from there you can pick your on-demand or always-on option. You can also put in other parameters to limit the user's session times if you want. And then here's where you start configuring the capacity of the fleet. There's some other more advanced details. You could go ahead and set the scaling policies up here if you want, or you can do it back over in the fleet after you've configured it. And there's also the ability to create an IAM role that will be available on the fleet instances for situations where whatever application the user is interfacing with might need to interact with other AWS services. That's a more specialized use case. From there, let's look at the stack. So if I'm the administrator and I wanted to say add another application to it, then at any time I can go back to my image builder like we did a minute ago, launch it, add the application, create a new image out of the image builder server, and then I can go to my fleet and edit it, and then I can pick a different image. And that's all you have to do. Once you update it, the users will have access to the new image. As far as AppStream goes, there's sometimes people might need multiple stacks, multiple fleets. Let's say you have two different groups of users with very different use cases. You might have some general business application users who don't need very much server capacity. And then you might have another group of engineers who are working with CAD applications. In those cases, you might want to have two different fleets because there's only 10 engineers, but there's 200 business users. You wouldn't want to have 200 high capacity servers provisioned just for the business users to use. Saw a question there. Yes, Msjc did have a presence in AWS. That was part of the migration that we were working on them with at the time. And their actual environment is slightly different from this and because of the way their environment was already set up, but it's basically set up the same way. And we took what we learned there to build out the remote solution here.
Hey, Jay,
Yes.
if I could ask you to try to transition in about a minute, and that way I'll give time to go through the rest of wrap up the presentation and let us finish on time, that would be great.
Sure. Yeah, I'm just about done. The only other thing I was going to mention is about the stacks here. The stacks basically have configuration for the fleet and everything below it. So you can choose to give the users access to OneDrive. If you have a corporate OneDrive set up, you can give them access to it through this. You can control their clipboard access, and there's, you can make their changes that they make on their instances persistent. So when they log back in, their environment will be preserved or not. And then you can brand the login page. Like you saw, the Msjc page was branded, and you can add other website links that you might need to add to it. All right, and that's about all I wanted to talk about there. So I'll turn it back over to you, Scott.